All right, so this is AP 2005 free response number 6, no calculator. It gives you a differential equation, which I accidentally cut off. dy dx equals negative 2x over y. It says on the axes provided, sketch a slope field. And again, it is simply taking the values. The reason there are no lines here is because on the x-axis, y equals 0. And the derivative will be undefined at y equals 0. So there are no lines. I'll just do a couple of the points here. If I pick this one, which is 0, negative 1, it's 0 over negative 1, which is the slope of 0, which is the line's there, it's just really short. All right. All the other fields are shown here. You get it by plugging in the coordinate points. Like this coordinate point would be 1, negative 1. So you end up with positive slope of 2. All right. You just want to make sure you slope it. Remember, a 45-degree line is supposed to be a slope of 1. This probably should be a hair steeper, okay? But again, that is the slope field. Make sure you catch the undefines. Letter B, let y equal f of x be the particular solution to the differential equation with the initial condition f of 1 equals negative 1. Write an equation for the line tangent to the graph at 1, negative 1, and use it to approximate 1.1. All right, so the first thing is they're going to give you an initial condition, all right, and they're going to write an equation for the line at 1, negative 1, all right? Now, first of all, we got to know the slope. So I'm going to do the derivative at 1, negative 1, that initial condition. And when I plug that in, I'm going to get negative 2 over negative 1. So you agree the slope is positive 2? So we have a slope and we have a point. So let's make an equation, point-slope form. All right, so we get y minus a minus 1 equals 2 times x minus 1, point-slope form. So y equals minus 1 plus 2 times x minus 1 if I move the 1 to the other side. So there's an equation y equals. Now, they want us to use it to approximate 1.1. So we're going to evaluate this at 1.1. 1.1 minus 1, I get negative 1 plus 0.2. I think the answer should be y equals negative 0.8. All right? So the approximate answer is f of 1.1 is approximately negative 0.8. Okay? And that would be letter B. And you got to include the line when you do this, okay? You got to have the equation of the tangent line also. All right. That takes us to C, letter C. So I'm going to erase this. And I'm going to go back up the board and change my view so we can read the problem a little better. Find the particular solution y equals f of x to the given differential equation with the initial condition f equals 1 to negative 1. Now they're asking us to do an antiderivative, right? And again, number one thing, you recognize immediately that this has two parts because the derivative has two variables. You must separate variables. And that is going to be a 2-point step on the AP every time. So again, I'm going to multiply by y dx on both sides and get this. Now, since all the y's are on the left, all the x's are on the right, we can integrate, all right, both sides, okay? So, if I integrate both sides, I end up with, how about y squared over 2, right, equals negative 2x squared over 2 plus the constant. Don't forget the constant, that's going to be a point. All right, they want us to evaluate a particular solution when x is 1, y is negative 1. And that's from this initial condition. So I'll plug that in, and I'll find C. Let's see, if I do that, I get 1/2 equals negative 1 plus C. So I think C is going to become 1.5 or 3/2. And last step is it wants a function y equals. Number one mistake I think with students at this point is they get real excited and they write this answer right here, and they might simplify like they should, all right? And the problem is you can't leave it in terms of y squared. You've got to solve for y. But the nice reason I didn't simplify is I see everything is over 2. So now I just take the square root. And when I take the square root, I'm going to get a plus or minus answer. And the question you have to ask yourself, is it going to be positive or is it going to be negative this time? And because the y value is negative, the negative has to occur from the outside the radical. So I won't make it plus minus, I'll simply make it minus. And that would be the solving for y. Alright, and again, this is either a 5 or 6 point problem on the AP. You must separate variables. The number one step is here, alright, and you must remember the constant here, and you must, after solving for it, solve for y. That's the free response problem. Thanks for listening.